Alright, we're going to talk about polygons and angles today, and the first thing you need to know is how to find the angle measure of any polygon. So the total angle measure, and that's with this formula, 180 times n minus 2, where n equals the number of angles. So let's say we have a 12-sided figure. Well, a 12-sided figure is also going to have 12 angles. So you put that into the formula of 180 times 12 minus 2. 12 minus 2 is 10, so you would do 10 times 180. So a 12-sided figure would have 1,800 degrees. If we wanted to go one step further and find out what each of those angles would be, we would take that 1,800 and we would divide it by 12. So if we divide this by 12, we're going to get an answer of 150 degrees. So if it's a regular polygon with 12 sides, then each of the angle measures would be 150 degrees. Alright, so let's prove that formula we just did. Hopefully you know that any triangle has 180 degrees. So a triangle has 3 angles minus 2. Our original formula is 180 times n minus 2. In case you forgot. So 3 minus 2 equals 1. 1 times 180 equals 180 degrees. And we know that a triangle has 180 degrees. If we were to do it for a rectangle, so that'd be 180 times 4 minus 2. 4 minus 2 is 2. Times 180 equals 360 degrees. So a rectangle has 360 degrees. Hopefully you already knew that one too. So we're just proving that that formula works for any polygon. If it's a regular polygon, then you can divide it by whatever number of sides it has to get the angle measure of each angle. If it's not a regular one, then you can't do that. Alright, now we're given that a pentagon has angles that measure 80 degrees, 115, 130, and 85, and we need to find the missing angle measure. So first we need to use our formula, 180 times 5 minus 2. So that would be 180 times 3. And 180 times 3 would give us 540 degrees in a pentagon. Now to find the missing one, we need to first figure out what we have so far. So we're going to take those numbers. So I'm going to start with the biggest one, 130, then 115, then 85 and 80. And I need to find a total. So I'm going to add those up. 5 plus 5 is 10, 4, 5, 5 plus 16, 21, 2, 3, 4. So I have a total of 410 degrees. So I take my total and I subtract it from the total that a polygon must be, and I get 130 degrees. So our missing angle measures 130 degrees. Alright, one other thing I didn't cover in my previous videos is alternate interior and alternate exterior angles. So alternate means they're on either side of the transversal, and interior means they're between the two parallel lines. So if you look at angle 4, its alternate interior would be angle 6, and they are congruent because they are alternate interior. So the other set of alternate interiors would be angle 3, it's in between the parallel lines, and the one that's alternate from that would be angle 5. So angle 3 and angle 5 are congruent because they are alternate interior. Alternate exterior is going to be the same thing, only on the outside of the parallel lines. So if we look at angle 1, it's going to be congruent to angle 7. And then angle 2 is going to be congruent to angle 8. Alright, one more proving congruency. So, in this shape, looks kind of like a bow tie, we're given that angle B is congruent to angle E, so you might want to draw in B and E are congruent, and then BC is congruent to EC. So we have angle side, and we need to prove congruency. Well, if you look at angle C there, those are vertical angles, and by definition, vertical angles are also congruent. So these shapes are congruent by angle, side, angle. And the way you would write that they're congruent, is you have to pick a point. So let's say we start at D. So if I started at D, so triangle DEC is congruent. Now I have to go the same direction. So I went from the angle I have nothing on to the angle I have 1 to the angle I have 2. So I'm going to do the same thing for the other one. So I'm going to start at A because I have nothing on that one. Go to the angle I have 1, which is B. And then go to the angle I have 2 little marks there, C. So triangle DEC is congruent to triangle ABC. If you'd gone a different way, if I had gone BAC, I would have had to say EDC. So it all depends on which direction you're going and where you start on being able to name those triangles correctly.